Have you ever gazed up at the sky, seen a massive metal bird soaring effortlessly, and just wondered, how on earth does that thing stay up there? It seems to defy logic, right? A machine weighing hundreds of tons, just floating among the clouds. Well, today, we're going to demystify the magic of flight. By the end of this video, you'll understand the incredible science that lifts these giants off the ground. It all boils down to four fundamental forces: lift, weight, thrust, and drag. Imagine these four forces in a constant tug-of-war. For an airplane to fly, these forces have to be in the right balance. Let's break them down one by one, starting with the two vertical forces, weight and lift. Weight is the easy one. It's simply the force of gravity pulling the airplane down towards the center of the Earth. Everything has weight, from the fuselage and wings to the passengers, cargo, and even the fuel. The goal of flight is to overcome this downward pull. And how do we do that? With the opposing force, lift. Lift is the superstar of aviation. It's the upward force that pushes the airplane into the sky, and it's generated primarily by the wings. Now, this is where it gets really cool. The shape of an airplane wing, known as an airfoil, is specially designed. It's typically curved on the top and flatter on the bottom. As the plane moves forward, air splits to flow over and under the wing. Because of the curved upper surface, the air traveling over the top has a longer distance to cover to meet the air from the bottom at the back edge of the wing. To cover this longer distance in the same amount of time, the air on top must move faster. This is where a principle from physics, known as Bernoulli's principle, comes into play. It states that faster-moving air has lower pressure, and slower-moving air has higher pressure. So we have low pressure above the wing and higher pressure below the wing. This pressure difference creates a net upward force, pushing the wing and the entire airplane upwards. That, my friends, is lift. It's like the air itself is lifting the plane from below. But wait, there's another important factor here: Newton's third law of motion. For every action, there is an equal and opposite reaction. The wing is angled slightly upwards, which is called the angle of attack. As the wing moves through the air, it pushes the air downwards. In reaction, the air pushes the wing upwards. So, lift is a combination of both Bernoulli's pressure difference and Newton's action-reaction law. Together, they create the powerful force needed to conquer gravity. So, we've covered the up and down forces, lift and weight, but an airplane won't generate any lift just sitting on the runway. It needs to move forward. This brings us to our horizontal forces, thrust and drag. Thrust is the forward-pushing force that propels the airplane through the air. This is generated by the engines. On most commercial airliners, you'll see jet engines. These engines work by sucking in a massive amount of air at the front, compressing it, mixing it with fuel, and igniting it. This creates a powerful, high-velocity jet of hot gas that shoots out the back of the engine. Again, Newton's third law is at work here. The action of the engine pushing the gas backward creates an equal and opposite reaction, pushing the airplane forward. It's an incredibly powerful and continuous push. But as the airplane surges forward, it encounters an opposing force: drag. Drag is essentially air resistance. It's the force that tries to slow the airplane down. Think about sticking your hand out of a moving car window. The force you feel pushing your hand back? That's drag. Every part of the airplane, from the nose to the tail, creates some amount of drag as it moves through the air. This is why airplanes are designed to be so sleek and streamlined. Engineers work tirelessly to minimize drag, creating smooth surfaces and aerodynamic shapes. The pointier the nose, the smoother the fuselage, the less air resistance there is. So, for an airplane to accelerate or maintain a constant speed, the force of thrust must be greater than or equal to the force of drag. Now, let's put it all together. To take off, the pilot increases the engine power to generate a huge amount of thrust. The plane accelerates down the runway, and as its speed increases, the airflow over the wings generates more and more lift. Once the lift becomes greater than the airplane's weight, the plane lifts off the ground and begins to climb. The battle against gravity has been won. Once the airplane reaches its desired cruising altitude, the pilot adjusts the engine power and the plane's pitch. In stable, level flight, all four forces are in balance. Lift is equal to weight, and thrust is equal to drag. The plane is in a state of equilibrium, allowing it to cruise smoothly for thousands of miles. But what about turning, climbing, or descending? How does a pilot control the aircraft? This is done using control surfaces on the wings and tail. On the back of the main wings, you have ailerons. When the pilot wants to bank or roll the plane to the left aileron goes up and the right aileron goes down. This decreases lift on the left wing and increases it on the right, causing the plane to roll to the left. The opposite happens for a right turn. On the horizontal part of the tail, you have the elevators. Moving the elevators up or down changes the pitch of the aircraft, making the nose point up or down. This allows the plane to climb or descend. Pushing the control yoke forward lowers the elevators, pitching the nose down for a descent. Pulling back raises them, pitching the nose up for a climb. Finally, on the vertical part of the tail, you have the rudder. The rudder controls yaw, which is the side-to-side movement of the plane's nose. It works just like the rudder on a boat and helps in making smooth, coordinated turns and correcting for crosswinds. By using these three control surfaces, ailerons, elevators, and rudder, the pilot can maneuver the airplane with incredible precision in three-dimensional space. So, let's recap the entire process. Thrust from the engines overcomes drag, pushing the plane forward. This forward motion creates airflow over the specially shaped wings. The faster air on top creates lower pressure, while the slower air below creates higher pressure, generating the upward force of lift. When lift is strong enough to overcome the downward pull of weight, the airplane flies. The pilot then uses the control surfaces to navigate the skies. It's an amazing symphony of physics and engineering, a perfect balance of four fundamental forces. It's not magic, but a brilliant application of science that allows us to travel the globe, connect with people, and explore our world in ways our ancestors could only dream of. The next time you're on a flight, as you feel that powerful push back into your seat during takeoff, you'll know exactly what's happening. You're experiencing the incredible power of thrust, building up the speed needed for the wings to work their aerodynamic wonders and lift you into the sky. I hope this has cleared up the mystery of flight for you. It's a topic that beautifully blends simplicity in its core principles with incredible complexity in its application. If you enjoyed this breakdown and learned something new, please give this video a thumbs up. It really helps the channel. And for more deep dives into how our world works, don't forget to hit that subscribe button and turn on notifications. Thanks for watching, and fly safe.